Hey guys, welcome back to the channel. So it has been quite some time since I made my last video, and this video is just a continuation of this Golang backend learning series where I will be developing a full end-to-end application. So if you look at the last video, the links I have provided down in the description. If you just look at the video, then I have explained the whole system that we are going to design, and now we will actually start coding the system. So we will have a backend where the user will send a request. The data will be saved to Postgres database, and that will be synced to Elasticsearch, which is optimized for searching, and it is the industry standard, the de facto industry standard. So also in the video we discussed that how will our schema look like. So this is the schema actually, this is the use case where the user signs up. So when the user signs up, the user information which is saved in the user table, which has ID, username, created at, updated at, and deleted at, that is saved in the user table in the Postgres database. Then the user also posts a blog. That blog is also saved in the blog table, which has ID, name, content, created at, updated at, and deleted at. And now when the user sends a fetch blog request, that goes to Elasticsearch. So the data that was saved in the Postgres database, it is synced to Elasticsearch, and then it is fetched by the user when they query the GET request, when they fire the GET request. So this is the example. Let's say that we post some blog which has some metadata, name, and date posted. And let's say the blog is an example blog, Golang is awesome, it is titled, which it surely is. And the content is that Golang is a programming language developed by Google. So this blog will be actually saved to Postgres database, and it will be synced to Elasticsearch. Now, since Elasticsearch is optimized for searching, when the user fires a GET request, that will directly go to Elasticsearch. So let's see that how we can code this up. So in the very first video, we coded a simple application, which was a simple HTTP server. And when we hit the HTTP server, we get a response back, which is welcome. The server is started at port 3000. So if I just go ahead and run this server, go run main.go. Now when I try to curl localhost 3000, I will get this response back, which is welcome. So we can see that the server is working fine as before. So now what we will do is we will actually create a Docker compose file. Let me know in the comments below if you would like a full dedicated tutorial on Docker. I can explain the necessary parts. So this is a Docker compose file. So the idea is that I don't want to install Postgres on my local MacBook. So what I'm doing is that I'm starting up a Docker container which has Postgres installed in it. So the Docker container is kind of a virtual machine or something that I can just use for the sake of this tutorial or for my own purpose. And I can even use this in production if I want. But for now, for this tutorial, I don't want to have the tension or headache of installing Postgres on my machine. So I'm using a Docker container instead, which has a Postgres instance running inside it. And now I'm simply calling this Postgres instance for all my purposes. So the container name is mydb-pg container. It uses the latest Postgres image, and these are the environment variables. The database is mydb, the Postgres user is Postgres, Postgres password is Postgres, and this is an important thing. So I'm mapping my local port 5432 to the container port, which is 5432, where the Postgres is listening. And you can see that I'm also mounting this volume. So I will just create a migrations folder where I will create this db init up.sql, which will be mapped to the the Postgres, the init.sql file inside the Postgres. So when this container starts up, the migrations will be applied automatically. So I will just go ahead and create this migrations folder, and I now need to create this file .up.sql, and for every up file we also need to create a down file, so down.sql. So now let's create the tables. So I've just copy pasted this code. So what I'm doing is that as discussed here, the user table has ID, username, created at, updated at, and deleted at fields. So I will just create a table if it doesn't exist, users, and inside that table we have the fields ID, username, created at, updated at, and deleted at. So these fields will be there. And I also need to create a down query. So drop table if exists user. So this is a down query. This will just drop the table if it exists. So I think this is done for now. I just need to run a docker compose up command. I will just go here and do docker compose up -t. Docker is not running on my PC. I will just start it first. I will start the Docker desktop application, which will start the Docker daemon in the background. Now when I run docker compose up -t, so this -t flag is to run this docker compose in a detached mode, else it will be printing all the logs and everything on this terminal and we won't be able to do anything here. So I'm just doing docker compose up -t, which will start all the services mentioned here. And for now we just have this single Postgres service. So now running this command, we can see that this is created. It created a network, go server my network. So it created a default network over which all these services will interact. For now we only have this single service, so we don't need to worry about that. And it also created a container. So now if I docker ps, you can see that we have this Postgres latest container running, and it is running fine. We don't see any problem. Let's just exec into the container. So my db pg container, I should have chosen a smaller name, I guess. So you can see that I have exec inside the container. And okay, so if I will create a new database, which is Postgres. Name is local test connection. Socket is this. User is Postgres. Password is Postgres. Database name is MyDB. SSL mode preferred, but that is not not necessary. So I will just test this connection. So it is able to connect to this. Now if I just connect to the database, I can see the users table which is created. For some reason I'm not that good at database connections, like at database queries, so I don't know why I couldn't see that table. Show tables. Okay, we all know that query is dt. So did not find any relations. And if I use MyDB, okay, it again shows did not find any relations. I don't know why. Select star from users. Relation users does not exist. Use MyDB. How to use a DB in Postgres. Okay, it is /c MyDB. Okay, now I'm connected to MyDB as user Postgres. And if I list the schemas now, you can see that we have this users table. So two more commands that we learned. C is for connect, mydb database name, and then /dt is to view the tables. I could have edited this section out, but I'm not doing that because I want the students to learn from this. So these are the commands, and if you are not familiar with the command, you can always use something like table plus, which shows us all the schemas that we have in the database and also the rows that are present. So this is a good UI to see your database. So this is success. And just to show you something, if I create something here, let's say ID is 1 and username is ABC. So if I just create this entry and let's say I do docker compose down, so this will shut down the database. And you can see that this is disconnected. We cannot connect to it. Now, if I just try to do this again, docker compose up -d, it will start this database and this is again connected, but that data is not persisted. This is because I have not set the volume here. So inside the Docker file, if I set some other volume here, it will actually persist the data. So I need to, like, I think there is some //data folder or something which I need to set here. So that will also save it locally on the disk. And whenever I run this Docker compose file again, it will bring that back up. But for now, I'm not doing that because I will be testing it and there might be some data which I don't want to save on my local storage, but I will show that sometime in the near future. So yeah, this is the end of the video, and in this video we learned about starting the database as a Docker container using the Docker compose file. The APIs are working as they were working before. We also need the migration scripts. So this is up.sql and this is down.sql. Inside up.sql we will be creating the table, the users table, and similarly in the down we will be dropping the users table. So this is it for the video. If we want, we can actually create other tables, but I will do that in the next video because this video is extending for too long, I guess. So yeah, thank you for watching this and see you in the next one. If you like this video, then consider subscribing to the channel. As an experienced blockchain developer and a FANG engineer, I know the topics required to actually understand core distributed systems. In the future, I will be making more such no-nonsense videos on programming, DevOps, system design, and of course my favorite topic, blockchain. Have a nice day, and I hope to see you back in the next one.